Okay, so let's write this in terms of f at x, where f at x is the reciprocal function. Now, you always factor out the number in front of x. If there's number other than 1, you factor it out, and you get this. Now, we have x plus 3, and then we have times by 3, and then we have the reciprocal, right? So look, we have the plus 3, second, we have the times by 3, and then 3, we have the reciprocal function. We flip it upside down. So this will be written as the following: x plus 3 times by 3, and you put that into the reciprocal function. Okay, of course, you could have rewritten this as 1 over 3 times by x plus 3 and written it as 1 over 3 f at x plus 3. But I'm going to write my solution as the way it's written, without the manipulation, without taking the number out. Is that okay? Do you see that they're the same thing? Now, from here, the transformation mapping, the y doesn't change. The change only occurs to the x. And the first change is this, right? So if you have 3x plus 3, if I want to get a, the first thing you got to do is divide by 3. So you do x divided by 3, and then you minus 3. That's the transformation mapping. So for example, the origin goes to minus 3 and 0. 1, 1 goes to 1 over 3 minus a third, so that's minus 2 and 2/3. And negative 1, negative 1 goes to negative 3 and 1/3 and negative 1. I'm just following this formula exactly. Okay, so let me try to draw this. Negative 1, negative 2, negative 3. So here's my asymptotes. Vertical. Horizontal is the x-axis. And we have negative 2 and 2/3 and 1. Right there. Okay, look. So remember we talked about this? If you have a rectangle here like this, there has to be a rectangle this way too. And that point, because this length is exactly 1/3, this point is going to be negative 2 and exactly 1/3. Okay, and the graph will pass through these 2 points. Like this. Like that. Okay, and then negative 4, it'll also go down exactly 1/3. 1/3. And it's going to be negative 3 and 1/3 and go down once. Like this. So this was we discussed this in class, right? The symmetrical property of hyperbola, the reciprocal function.